here. Perfect. All right, so solving equations. I'll talk a lot. And probably when you're watching back the video, you all can make notes from what I say. I will make notes as well. All your job for me is to just pay attention, right? Rock back, pay attention. I want everybody's undivided attention while I'm teaching. You will have the leisure of going back in the recording and write while I talk, right? That is all the leisure. I'll have the leisure of fast forwarding through the recording and see, right, I don't know this, I don't take down notes for this, let me fast forward. You'll have the leisure, okay, I didn't understand this when Sir taught it, let me go and watch over that little piece and see if I could make sense out of nonsense. So I have that leisure available at all when I upload the videos. I will also send across these notes to you guys, just like in class, just like in school. So solving equations. Now, when we're talking about equations and we're solving something, we must have an equal sign in it. All right? Your equal sign is your indication that, yo, I'm looking at an equation. If I don't have an equal sign, I cannot solve for anything. Now, in an equation, there's these things called variables. And we had to learn to deal with variables. So I'm asking a question and I want to put it in the chat, but put it as a private message in the chat. All right, so everybody will give me their independent answer. Tell me, what is this? X plus X. Put it in the chat. Tell me, what is this? All right, I've seen some answers coming in. Good, 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 good. All right, I've seen different answers coming in now. All right, now this concept of variables, remember, a variable is any letter in this word. What I want you all to start doing, everybody likes to eat fruits, correct? Bananas, apple, pear, a little kiwi, a little sapodilla, yeah? I want you all to imagine each variable as a particular fruit. So let me talk on the fruits basis here, right? I want to answer my verbally now. If I have one banana in this hand and one banana in this hand, how much bananas do I have? Two bananas. So one banana plus one banana is two bananas, correct? Good. Suppose now I have, and I'll draw on the board, I have two tables. One table here and a next table here. On the first table, table 1 and table 2, on the first table, I have 3 bananas, 4 oranges, 6 apples, and let me say 10 pears. Table 2, I have 11 apples, 16 bananas, 2 pears, and 6 oranges. In total, how much bananas do I have?
19, sir.
19 bananas, yeah? How much apples do I have?
17.
17 apples. How much oranges do I have?
10.
10.
And how much pears do I have?
12.
12.
Very good. If you can do this, you can add variables. If I have 1x over here and I have 1x over here, how much x's do I have? 2x, correct? So x plus x is 2x. Yeah. Now, I've seen students do this already, where they say, x plus x. I see there's all the different answers I get, right? I get 2x. A man say 2x squared. A man say x squared. The answer is 2x because I can add like terms. We do our next one. X squared plus 3x. Tell me what this is in the chat. Try a thing. I don't care if I get wrong. I try a thing. I've seen different. Everybody give me a different answer so far. Hopefully one of them correct. Now is the piece where we transition into comparing the apples, bananas, and things to the variables. Look at the two tables. I'm looking for a total in the end. All right. I have 3 bananas on one table and 10 pears on the other table. And I have 11 apples on the next table. All right. And I'm looking for how much fruits I have in total. Take off this, and I'm taking off this. How much fruits do I have in total? Like, if you were to tell me, specify the fruits on each table, how will you tell me that? You can verbally tell me if you want. Not a difficult task. It's an easy task. It's not a trick question, fellas. I'm helpful. On the two tables, I have 3 bananas, 10 pears, and 11 apples. Yeah? I have no more bananas to add on table 2. I have no more pears to add on table 2. And I have no more apples on table 1 to add to the 11 apples on table 2. I'll agree with that.
Yeah.
Treat each variable as a fruit visually. And you go see a banana, I know it's a banana. I know I can add that banana to our next banana. Treat each variable as a fruit. Visually, if the variables are the same, I can add them together. Just as visually, I have 2 bananas, I can add them together. Yeah? For number 2, these 2 variables, are they visually the same thing? Yes or no? They are not. One is x squared, and the next one is x. That come like adding apples to bananas. I can't do it. At the end of this table, all right, I will end up with so much of x squareds and so much of x's. I cannot add them together. Okay? Let me try the next one. 4x plus 2x squared plus 3x plus 6x squared. So tell me in the chat, when I find out the sum, look at the things that are the same and add them together and tell me where you get. Very good. 7x plus 8x squared. Because I can add the x squareds to the x squareds, I can add the x's to the x's. Yeah? Good. Making progress. Now, I'm taking it up a little bit here, right? Multiplication is commutative. What does that mean? Everybody know what commutative means? I want to establish one thing, fellas. Nothing wrong with saying no, so I don't understand. That's your purpose here, right? All your purpose here is to tell me, sir, I don't understand, I lost. So I'm feeling stupid. That is all your purpose here. Cool? It have plenty things in this world. I don't know. Right? And if I ask a question, my brethren sitting down across the room by me here, so could be like, hey, but he real stupid boy. But quite frankly, I do business. You could say what you want. If I don't know something, I want to know it. You understand? I want to know it. Kind of like, I know it. Mr. Dong, I afraid that man tell me I stupid boy. I do business. All right? Because at the end of the day, I want to learn something. I want to know what I don't know. So, if all I don't know something, do business. Sir, I don't know this. I will show you. I'm not going to watch nobody any differently. Right? I'm not. At the end of the day, all paying for a service. That is why I here. Seen? So multiplication is commutative. That means if I have 3 multiplied by 4, I can rewrite this as 4 multiplied by 3. It doesn't matter the order in which I write it down, as long as it's multiplication, I can put it in any order I want. It works for letters as well. A by B is B by A. ABC is the same thing as BAC, because multiplication is commutative. So when I'm adding variables, although they will not visually look the same off the get-go, that don't mean they are not the same off the get-go. Let me see. By some miraculous scientific phenomenon, a man crossbreed a banana, a pear, and an apple. And he get a banana pear apple. Yeah? And the next scientist do so, and he crossbreed a apple, a banana, and a pear. And it's the same thing. I still crossbreeding 3 fruits. It's the same thing. So if a man crossbreed 4 of this, and a next man crossbreed 2 of this, and at the end of the day, it's 6 of the same fruit again in the end. When we have variables that mix up, try to take this approach. For example, if I have 2x plus AB plus 3x squared, I'm making it a long one, right? Plus 4BA plus 6x minus x squared. Before we do the question, I want to let you observe it and tell me which fruits are the same. Start with the 2x. Which other fruits I have is the same thing as that? Or which variable is the same?
6x.
Nice. 2x and 6x. Yeah? AB. Which other variable is the same as AB?
4AB.
Well, 4BA. Yeah? But BA and AB, we just established is the same thing. So I can't add those two together. What about the x squared? Well, the 3x squared, sorry. Did it have any other variable looking like that?
Yeah, that's right.
Nice. So we can add all those things together as we listed them just now. So the 2x could add to the 6x and I get 8x. I'll agree with that. The AB could add with the 4BA and I get what? How much?
5BA.
5BA or 5AB. It don't matter how you write it. Yeah? But traditionally, I mean, AB does song with this rule of the tongue a little nicer. Yeah? 3x squared minus x squared is what? Ding, 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 ding. 3x squared minus x squared. How much?
2x
2x squared.
Plus 2x squared. So we get familiar adding all these different variables together. Yeah? Grouping them, adding them. Right, so I'm gonna leave this one. Actually, do this one for fun. Plus 2BAC plus, I will put everything as pluses for now, right? 11y x squared minus 2. Gimana, Sari? Big up. All right. So far, one man give my correct answer. All right. Our next man give my correct answer. All right. 3 men give my correct answer. Now, yes, huh? Yeah. Now, your answer, I just give another hint, has 3 terms in it. All right. 3 terms in it. So you have something plus something plus something. All right. I've seen some people give me 4 terms. It could be simplified further. All right. I'm now give me 2 terms. No, that 3 terms. Sorry. All right. So, Dylan, check over the addition. Orlando, simplified. Yeah, you forget the why, but check over your addition, Dylan. Pull out your calculator. Much better. You see it, Orlando? You seen what you could do? What you could simplify further? Much better. Much, much, much better. So 6 ABC and 2 ABC. BAC is 8 ABC. Right? You can put BAC, CAB, any combination of A, B, and C. Plus, this and this is the exact same variable. Yeah, just I write it in different positions. And at the end of the day, that is 15 x squared y minus 2. I have nothing to add to the 2, so it remains as minus 2. Yeah? Cool. Now, as we get that out of the way, let me start focusing on equations. All right? Now, when we're talking about equations, like I said, equations have an equal sign. Yeah? We need to learn how to solve these things. Now, there's a rule in maths when we're dealing with equal signs. If I have an equal sign, I can have things on the left and I can have things on the right. Let me put in some things. 6x plus 3 minus 4y, 2y minus 11 plus 3x. There's a rule that says, if I pick up something and I jump across the equal sign, the sign in front of that something changes. So for example, if I pick up 3, I'm picking up 3 and I jump in the equal sign, he becomes minus 3. As long as I cross an equal sign with a term, the sign on that term changes from positive to negative or negative to positive. And it's extremely important to identify a number with the operation. So I want Ola to be very specific. What is this? Extremely specific. What is that a square of there? If you were to say it to me verbally, what are you going to say? Yeah, Dylan want to know what?
Plus 6x.
Say that again.
Plus 6x.
Very good. Plus 6x. Yeah? Start defining your terms with the operation attached to them. So if I move 6x across, it becomes minus 6x. Yeah? This here, this is not just 11, that's minus 11. When I move the minus 11 across, it becomes plus 11. Yeah? Now, in an equation, when I solve, I'm solving for a variable. And that variable tells me, okay, this is the value of the letter that satisfies the equation given. So if I ask a little something here, if I say 2x is equal to 4, what is x? Easy question. What is x? X is 2. Now we know this based on we knowledge on basic mathematics. X is 2. When x is 2, this side here becomes 2 multiplied by 2, which is 4. Yeah? So x is equal to 2. This value satisfies this equation here. Yeah? If I have 3x is equal to 18, what is x? X is 6. Again, common sense. And this value 6 satisfies this equation here. Yeah? What about this one? 2x plus 1 is equal to 4. Off the top of our head, some of us could do it, but off the top of our head, it's a little more challenging than the first two, correct? It is a bit more challenging. So let me see what we can do. Before I do that, I want to explain one thing. X is a variable, correct? Why it's called a variable? Because it can vary in value. Variable. Look at the first two examples here. In the first example, x was 2. Yeah? In the next example, x was 6. Which means x could be any number in this world, depending on the equation given. That's why it's called a variable, because it can vary in value. Whereas numbers are constants. 2 will remain 2. The weight of 2, if I just use this a lot, the weight of a number, the weight of 2 is going to remain 2 from now until I dead, until other dead, till other children dead, and so on. The weight of 2 remains 2 forever. Whereas the weight of x could be 2, could be 6, it could be 1 point something, it could be 100 and something. Yeah, the value of a variable can change. That's why it's called a variable. The value of a constant remains constant forever. That's why it's called a constant. Let me learn the steps to solve an equation. Step 1 is to bring all the terms that has the variable we are solving for on the LHS, means left-hand side. Okay, gentlemen? LHS is left-hand side. So as I list the step, I'll do the step one time. 2x plus 1 is equal to 4. So I'm bringing all the terms that has the variable we are solving for on the left-hand side. In this equation, only one term has x in it. Yeah? And that one term is already on the left-hand side, so I mean, good to go. 2 is the, again, I wouldn't say bring, I'll say send. Send all other terms on the right-hand side. Yeah? 2. Cool. Send all other terms on the right-hand side. All right. So all other terms go be the plus 1. So the plus 1, brother man, you gotta go. 4, when I jump the equal sign, it becomes minus 1. Good so far. 3. Simplify both sides. What could add, what could minus, minus? Two x is 3. And step 4, I'm gonna be very technical here, is to divide by the coefficient of the variable on both sides. Now, what is the coefficient? Coefficient means number in front of. So in this case, the coefficient of x is 2 because the number in front of x is 2. Yeah? So 3x, y, z. All right, easy exercise here. What's the coefficient of x? You can verbally tell me. 3. What's the coefficient of y? Remember, coefficient means in front of. So what's in front of y? Again, you all can verbally tell me. We're in front of y, fellas. I want everything in front of y, eh? Everything that's in front of y. That's the coefficient. That's what coefficient means. One man give me so far. 2 men give me so far. 3 men. What is in front of y? Look at it. It's not your question. Watch it and you will see. Come on, Andra, we can figure.
So Z.
Huh?
Z.
In front of, not behind.
Oh,
What's in front of y? Tell me.
X.
Everything in front of y.
3.
3x. What's the coefficient of z?
Y.
Everything. Everything, Orlando.
3xy.
Very good. 3xy. Yeah? That's your concept on coefficient. Coefficient is everything in front of it. Everything. Now, when I say divide by the coefficient of the variable on both sides, I would like you all to write it down. What's the coefficient of the variable here? Two. Very good. So I'll divide by 2 on both sides. 2x divided by 2 is equal to 3 divided by 2. And this happens all the time when you execute step 4. The variable, the coefficient cancels out with each other, and I get x is equal to 3 over 2. And this is the value of x that will satisfy this equation. And we can double check our work and observe how we double check and we work here. Let's see in the calculator. X is 3 over 2. We now solve it. Yeah. So I'm going to substitute x is 3 over 2 back in our original equation to make sure my answer correct. 2, open bracket, 3 over 2, close bracket, plus 1. I supposed to get 4. I indeed got 4. So x is equal to 3 over 2 is the correct answer. All right, so I'm going to put a couple easy ones for you all to try. Try that one for now, and solving for x in the first one, and we're solving for y in the second one. And then we go have the challenge question where we have more than one variable in it. So big up. Solving for x in the first example, solving for y in the second example. Everybody here display Apex? No? None all display Apex? No, nah, man.
So, so that Apex, that no way. Way.
What does it do? Let's play Warzone.
I
FIFA.
wish so. I wish.
I do the second one. What that Apex trailer? I gonna watch it. Do that quick. Quick as you will. Right, I see one man give me the answer for the first one. A couple man give me the answer for the second one as well. I'm waiting for more answers to come in. Again, I don't care if all I get wrong, fellas. I really don't care. Right? I just want to, I want all to see where the mistakes is and fix it. We get some different answers now, man. Mhm. Mhm. Okay. Mhm. Mhm. All right. I'm gonna do the first one. Same 4 steps every single time. I solve it for x. So I can do steps 1 and step 2 in the same breath. In the same breath I'm moving the x's, I can move everything else. So I'll move the x and I'll put the x on the arm left. So I'll get 4x minus x is equal to minus 2. I did not touch the minus 2. So he stays minus 2. But I am moving the positive 6 across and he becomes negative 6. 4x minus x is 3x. Minus 2 minus 6 is minus 8. I'll divide by the coefficient of the variable on both sides. 3x over 3 is minus 8 over 3. Bam, bam. X is minus 8 over 3. Yeah? Next. More terms, so it will be a little bit more challenging than the first one. Move all the y's, move everything else. Minus 2y, he remains there. The 4y comes across, minus 4y. The 3 remains there. The minus 2 remains there. This 6 becomes minus 6. And this 6 becomes minus 6 when I move it across. Yeah? So there's nothing wrong if I use a calculator to work it out. Nothing wrong with that at all. It's confirmed I can add these things together. Yeah? Because the variables are the same thing. Just input the numbers on a calculator. Minus 2, minus 4, I get minus 6. Next, 3 minus 2 minus 6 minus 6 minus 11. Be careful. I have to divide by the coefficient of the variable, which is minus 6. Sorry, minus 6y over minus 6 is minus 11 over minus 6. Minus 6 and the minus 6 cancels out. Over here, a minus and a minus is a plus. So I get 11 over 6. Yeah? Good. I could rub this off. Again, all I could take down all the notes when all I watching back the video. If all I want. For example, we're gonna incorporate two variables in here now. 2x plus 3y minus 4. 6x plus 11y plus 12. I want all to tell me what y is and then tell me what x is. So this is two questions in one. First, solve for x, do your working, then solve for y. All right, so I get one answer so far. All right, let me jump in and try a thing there, fellas. So I'll solve for y first, right? I'll see my screen, right? I'll see my writing on it. No?
No, sir.
I'm gonna stop the share and I'm gonna stop the share. Bam. Seen my day? Seen my writing?
Yes, sir. Yeah.
Yes, sir.
All right. I'll solve for y first, okay? Now, when I'm solving for y first, I'll bring all the y terms on one side and I'll send everything else on the other side. So the 3y here remaining there, the 11y coming across, it becomes minus 11y. I have no other y terms, so I'll send in everything else across. 6x remains there, the plus 12 remains there. I have to move across the 2x, he becomes minus 2x. I have to move across the minus 4 and he becomes plus 4. Now I can simplify. I can add similar terms. 3 minus 11. Again, I don't know, so I jump in on my calculator. 3 take away 11 is minus 8. So I have minus 8y is equal to 6x minus 2x becomes 4x. 12 plus 4 is 16. Yeah? All good with me so far. Next, I'll divide by the coefficient of the variable. And for now, don't simplify nothing. Just divide by it and leave it just so. Minus 8y over minus 8 is 4x plus 16 all over minus 8. You go with you. Y is 4x plus 16 over minus 8. Now you are going to be tempted to do this. Bam, bam, and I get 2. Don't do that. That is wrong. Right? That is wrong. Whenever we have a division like this, and there's more than one term on either the numerator or the denominator, do not cancel. You cannot cancel. All right? Do not cancel. The only time you could cancel is if the top has a multiplication on it alone. All right? You could only cancel products. You cannot cancel sums on a fraction. Okay? All right, so that is the value of y. And this is going to be the value of x. I'll do it in a different color. Same thing, I will rearrange, but now I'm going to put all of the x terms on the left. So the 2x remains there. The 6x have to come across. Is equal to 11y plus 12 minus 3y plus 4. 2x minus 6x is minus 4x. 11y minus 3y. Again, I want to double check. 11 minus 3 is 8. 12 and 4 is 16. I'll divide by minus 4 on both sides. Minus 4x over minus 4. 8y plus 16 all over minus 4. You cancel with you. X is 8y plus 16 over minus 4. Again, do not cancel. All right, I see a couple men cancel. For Dylan, that will be correct when you cancel there. All right. For now, I don't want to cancel off nothing. We can learn how to do that operation a little further down the road. All right. So for now, brother man could stay as is. Right? You're comfortable with solving things like this? Yeah. All right. Make sure everybody get correct. If you get it wrong, please make your corrections. All right. Please. If you're still confused, make sure and ask. Okay. Make sure. All right. Would you believe we finish solving linear equations? That's it for solving linear equations. All right. Let me dive into a little coordinate geometry. Now, you all would have been exposed to coordinate geometry in the videos. All right. Anybody have any questions, by the way? Everybody good? Okay, good. All right, so let's dive into some coordinate geometry. We're going to talk a lot, and it's going to be along the same lines in the YouTube videos. So if you all want another probably perspective, you could go and watch a video, because I highly doubt I'll say the exact same thing. Coordinate geometry deals with our x and y axis primarily. X and y axis. Now, our xy axis has a name. And the name of the xy axis is called the Cartesian plane. Now, on our Cartesian plane, we can draw a lot of things. A lot of things. You'll ever wonder why we call it the xy axis? How many sleepless nights have you had, Dylan? Wondering, why is this called the xy axis?
A lot.
I
A
know that.
lot.
I can see it in your face. A lot. So that is why I here. Let me bring up this application. Bam, bam, bam. All seen GeoGebra. Good. Obviously, we know that how the vertical axis is our y and the horizontal axis is our x. Yeah. The reason it's called the xy axis is because we can draw certain things on the xy axis provided a condition is satisfied. That condition, it must have x and y variables, or it can have x's alone or y's alone in the equation. Have to. For example, if I have y is equal to 3, something will appear. If I have x is equal to 4, something will appear. If I have a combination of x and y's, y is equal to 4x plus 6, something will appear. If I have x plus y is equal to 5, something will appear. Yeah. As soon as I stray out of x's and y's, nothing will appear. Z is equal to 5. Nothing appears. R plus K equals 77. Who could? Pressure. Nothing appears. Yeah. So the reason we call it our XY axis is because we can plot equations, or we can draw equations that involve x's and or y's in them. Now, Pretel, suppose we had something called a IJ axis. We can only draw things that has i's and j's in the equation. All right. Suppose I have a AB axis. I can only draw things with a's and b's in the equation. Okay. You all understand that? So only equations that involve x's, y's, or x's and y's can be drawn on the XY axis. So Dylan, no more sleepless nights. Now, everything we did so far involved x's, involved y's, involved x's alone, involved y's alone, so far. Yeah. So theoretically, every single equation written today, other than number 5 and number 4, everything could be drawn on the XY axis. Yeah, everything. Now we need to learn, well, which equations look like what? 1. Properties of the equations on the XY axis 2. And how do we get the equations 3? So let me clear this off. The first thing we're going to learn in coordinate geometry is how to plot a point, how to read a point. Plotting a point is x first, then y. Again, x is my horizontal, y is my vertical. So I want to tell me, what is the coordinates of this point, this point, this point, this point, and this point? Put it in the chat. I'll zoom in a little more so I can see. A, B, C, D, and E. Tell me the coordinates of each point. I'll do A for you all first. When I read off a point, I read off the x coordinate, then I read off the y coordinate. So the coordinates of A is going to be 2, 3. And if I come here, 2, 3. I read off my x, which is 2, and then I read off my y, which is 3. Follow suit for all of them and tell me each of the points, the coordinates of each point. Good, 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 good. Right, waiting for the rest of all here. Nice. Good. So I could always check back all your work. I'm showing all the values here, right? In case I miss something. So far, everybody looked like they get correct, right? But in case I misread something, check over all the work with us, right? Now, a point on the XY axis has two coordinates. It has a X and it has a Y as illustrated here. The X is read first and the Y is read second. Cool? If I join 2 points together, I get a straight line. I'll agree with that. And a straight line could come in many, many, many variations. I could have a straight line like this. I could have a line going this direction. I could have this line here. I can also have a horizontal line and a vertical line. Cool? So let me hit the good Lord. Let me hit these things with a little color coding. You could go so, you could be a little green line, you could be a purple line, you could be a little, oh, color maybe blue, yeah, a little blue line, and you could be a yellow line. Good, good, good. So we could distinguish between the lines by their color. All right. Now, each line has some properties. If you remember before, I inputted an equation here and I got a line. Yeah. So to every line, I have some mathematical equation that I can use for that line. In this case, x plus y is equal to 5. I drew the line first. Did I break up any part there? Good. X plus y is equal to 5. I drew the equation. So I know the equation, the mathematical equivalent to the line. But in all of these colored lines, I do not know the mathematical equivalent to the lines. That is where we're going to learn how to figure out the mathematical equivalent for the lines. Now, if you realize, each of the lines are drawn in different directions. They are drawn at different angles, at different slopes. Yeah? Each of these lines has something called a gradient. A gradient tells us it's a number that tells me how steep a line is. So for example, this blue line here versus the green line, which one will have a bigger gradient? The blue line or the green line? The steeper the line, the bigger the gradient. Blue or green? No, someone might argue and say, sir, that is not blue. Right, that is blue. Which line is going to have the steeper gradient? Right, so one man say green, two men say green. Very good. So pretend this is a straight line here, if you're watching my camera. And this is a gradient of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, going all the way up until I reach maximum steepness. Yeah? All right. We have to determine how to calculate the gradient of the lines given it on our Cartesian plane. All right. So what we're going to do, We're going to bring this across in our notes. Now, like I said, you all can write down all the notes when you're watching back the recording and write down all the notes if all you want. Okay? I'll just be executing a lot of calculations. Or you can write down whatever notes all you want afterwards. Now, I'm going to refer to a line as the letters that define that line. For example, AB is the purple line. All right? So A has coordinates 2, 3, and B has coordinates 7, 6. I can use this information to calculate the gradient of AB, which will be the number responsible for how steep the line is. So the gradient of AB, and this is going to be the equation you all will use from now until forever for the gradient of a line. It's just y2 minus y1 over x2 minus x1. So then you will ask the question, but sir, what is y2, y1, x2, and x1? If you remember, every point comprises of 2 coordinates, an x coordinate and a y coordinate. x1, y1, x2, y2, it just distinguishes between one point and another point. All right? So for example, this is a x coordinate, this is a y coordinate, this is a x coordinate, this is a y coordinate. The ones and the twos just represents, okay, that's for my first point, and this is for my second point. It doesn't matter which one I put as x1, y1. Doesn't matter which one I put as x2, y2. I could have labeled A as x1, x2, y2, and I could have labeled B as x1, y1. Your calculations are going to give you the same answer. So the gradient is y2. Take a 5. y2 minus, take an x5, y1, 3, over x2, take a 5, take away x1, 2, 6 minus 3 is 3, 7 minus 2 is 5. So the gradient of this line, the gradient of this line is 3/5 or 0.6. Yeah? I'll say this, and I want this to be etched in your brain from now. In coordinate geometry, do not use decimals ever. Okay? Do not use decimals ever. GeoGebra does not give me fractions. It gives me decimals, but I'm just checking over my work here to show it, right? The gradient of AB was 0.6 based on the calculation. Bam, bam, 0.6. Yeah. Now, what I want all to do, that is the gradient of AB. We're going to calculate the gradient of ED, where E is minus 2, 6, and D is 7 minus 4. Now, I'll label it for you guys. It doesn't matter, but I'll put this as x1, y1, and this as x2, y2. I want you to be extremely careful here. Calculate the gradient of ED for me. So you'll write down the formula. Gradient of ED is y2 minus y1 over x2 minus x1. Oh, by the way, this y2 and y1, x2 and x1, the 1 is a subscript. So I don't want to see this, x1. I don't want to see that. The 1 is called a subscript, which is underneath the letter. y2, the 2 is underneath the letter. Okay? So go ahead, take your time, calculate the gradient of ED for me, and tell me what the fraction is. I expect him to get some different results here, if although take all the time. First, write down what y2 is, take a breather. Then put your minus sign, take a breather, then put your y1. Trust me when I tell you, it makes a lot of sense doing it that way. I see two men have answers there. Huh. So we see another variation here. The way in which I will say certain things, I'll have to pay attention to them, right? Pay attention to them. Remember I say, write down y2 minus. Take a 5, drink a little bit of water, eat a little beef pie, come back. Minus. Do the same thing again. This time you're going to eat a little chicken pie. Drink a little cokes, come back. Write down what y1 is. 6. Over. x2, take your 5, come back and write down your minus sign. Take your 5, come back and write down what x1 is, minus 2. Yeah? Do your thing. I stupid. I don't know what is minus 4 minus 6. I go on my calculator. Minus 4 minus 6 minus 10. 7 minus minus 2 is positive 9. Minus 10 over 9. That's the gradient of the line ED. Yeah? Now I will just put it in decimal equivalent to illustrate it on GeoGebra, right? Minus 1.11111. So GeoGebra, the gradient of this line, minus 1.11111 going on the road. Okay? Now, it leaves me wondering, well, so yeah, still just now tell us this, right? And I'm sure Samir would have this body in Samir since we do it. And Samir? Samir,
Yes, sir.
body in the end. Don't worry,
Yes, sir.
I go answer your question. I go answer your question. Don't worry. So say that the steeper the line, the bigger the number that represents the gradient. Yeah? How have a negative number there? How I have that means the line going backwards? Well, what I mean? With respect to gradient, we have 4 different numbers that can represent the gradient of lines. We have negative, positive, 0, and infinity. Those 4 different branches of numbers will represent different lines, specifically how the lines are drawn. So look at the purple line. The purple line going in one particular direction. The purple line going like this, correct? This is an indication that all lines drawn in this particular direction, it could be a little steeper, it could be a little less steep, but once it's drawn in this particular direction as AB, they will have a positive gradient. Whereas lines drawn in this particular direction, it could be a little less steep, will have a negative gradient. Yeah? So let me ask a question here. What type of gradient will CD have? Will it be positive or will it be negative? CD. Think about it. Watch the lines. Will it be positive or negative? It is a 50-50 chance, if you guess. CD, fellas. I don't want to know the number. I just want to know if it's going to be positive or negative. That's all I want to know. I'm answering negative. I'm answering positive. And next man say negative. Negative. Only one way to find out. Calculate it. Calculate the gradient of CD for me, guys. I'm not giving you all no writing. Exactly how I present my work here, fellas. I want all to present all your work just like that. Write down the 2 points, your x1, y1, your x2, y2, your formula, and then you're working. For CD. Big up. I'm waiting. One man give me an answer. The next man give me an answer. Next man give me an answer. Right, so while I'm working it out, I'm gonna write down the points and stuff. C is -6 - 1. And D is 7 - 4. X1, Y1, X2, and Y2. Gradient of CD is Y2 minus Y1 over X2 minus X1. C is -6. Sorry. Y2 is -4. Take away. Take a 5, take a pause. Y1 is -1. Make sure you do make that mistake. X2 is 7. Take away. X1 is -6. A minus and a minus is a plus. So I'm doing it a little different than the one before. 7 plus 6 minus 4 plus 1. If you're uncomfortable, go ahead and use your calculator. That is -3. 7 plus 6 is 13. So the gradient of this line is -3 over 13. So you'll see how important it is to just take that little pause. That little pause when you're writing down your Y1 and your X1 is so important, because I've seen it happen plenty times. Because, for example, because Y1 was a negative, you all will take for granted that this here is that negative sign on Y1. But no, that minus sign, a circle here, have to always be there, and then you write down Y1. Cool? All right. So let me put next line in the mix here. The pink line will be CE. Calculate the gradient of CE for me now, guys. -2, 6 and -6 - 1. -2, 6 and -6 - 1. Again, it doesn't matter which one you put as X1, Y1 and X2, Y2. I show you everybody would have put C as X1 and Y1, correct? I'm going to put C as X2, Y2 in my case. And you'll see you'll get the same answer. of EC or CE is the same thing. X2, I'm sorry, Y2 minus Y1 is 6. X2 minus X1 is minus 2. Minus 1 minus 6 is minus 7. This becomes minus 6 plus 2, which is minus 4. This is 7 over. Yeah. It's just a matter of taking your time. All right. Just take your time. All right. Now, although we didn't do much writing, we do plenty talking. All right. We did plenty talking. And like I said, I here to push work. Or you can take all the notes on your own. I'm going on send you all a copy of this. What I want all you to do, calculate the gradient of all the lines we didn't calculate so far, which is EB and BD. Right? Calculate those two gradients for me. When you're taking down your notes, do over AB and do over all the ones we did, just to familiarize yourself with that, inputting the X1s, the Y1s and such. All right. When the video renders, I'm gonna put it on the on a private playlist on YouTube and I'll send it on the group. All right. When I send it on the group, I'll have access to that forever until I delete it. All right. So I will have this class on YouTube to review over and over again. I'm gonna send the notes on the group, take it down, calculate the rest of the gradients. Anybody have any questions? All right, next class, we go in and talk more about coordinate geometry. We're going to talk a little bit more about gradient. When I'll calculate these gradients here, the red line and the yellow line, questions going to come up. I'll look out for those questions in the next class. And next class is when? Thursday. All right, so make sure and study all your work until Thursday, so we can just continue moving forward. All right, work on the weak points from today, work on them, take your time and work on them. And Thursday, we go build on the weak points more. Cool. All right, if you all have no questions, fellas, you all can go ahead and leave, and I'll see you guys on Thursday. Later.
Later.
Later, sir.
Later, sir.
Yeah, it does.
New folder. Of course. Class number